Okay, so you've learned all of the endocrine disorders that I wanted you to learn, but I need you to figure out how to categorize them. So, all of the endocrine disorders we've covered will fall into one of these four categories. They are either going to be a hyposecretion, meaning not making normal amounts, less than normal amounts, a hypersecretion, making too much, or two kinds of responsiveness disorders, meaning that the problem is not that I'm not making the right amount. The problem is that the target cells, for some reason, are not responding to the amount that I'm making normally. So let's talk about each of these types of disorders. So if we start out with this is just a random example. If we have, which is very common, the hypothalamus makes a hormone which regulates the anterior pituitary, which goes and causes the third hormone to be made or secreted. Then I have three in a row. Now, a hyposecretion or a hypersecretion can be primary, secondary, or tertiary. So what I want to do is I want to show you how this occurs, and we'll use thyroid hormones, T3 and T4, as the example. So stick with me for just a second. Okay. So let's tell the thyroid story and then we will break it. So the thyroid story starts with the hypothalamus. And the hypothalamus secretes TRH, which goes to the anterior pituitary. And that secretes TSH. Oops. And then TSH goes to the thyroid. And it secretes T3 and T4. Okay. And the normal feedback mechanism is, because it's lipid soluble, it can go all the way back to the hypothalamus and inhibit release of TRH, but it can also go to the anterior pituitary and inhibit release of TRH. So let's break it three different places. Okay, so if first we break it and we say, okay, let's do hyposecretion first. So the hypothalamus is doing just fine and it's making TRH, and the anterior pituitary is just fine and it's making and releasing TSH. But the thyroid is broken. Maybe it's got an autoimmune hypothyroidism and your immune system killed off your thyroid. What would happen is you would end up with plenty of TRH, plenty of TSH, and low levels of T3 and T4. So if I ended up with, actually it would start out normal, it would end up going high, and I'll tell you why in just a second. And this would be low, okay? What that tells us is that the problem is occurring at the thyroid. So the problem is occurring right here. So one organ, two organs, three organs. And we start from the bottom where the symptoms occur. This person might be exhausted, have all kinds of weight gain and that kind of stuff. So this would be a primary hyposecretion of thyroid hormones. Primary because it occurred right where the symptoms occur. So you go from the bottom, primary, secondary, tertiary. So now let's talk about what would happen if instead the problem was at the anterior pituitary. If the problem was at the anterior pituitary and we had a hyposecretion, what would happen is you would have gone in and you say, oh, I feel like crap, I'm exhausted. And they test your T3 and T4 levels and those are low. But then they test your TSH levels and those are low. And then they look at your TRH levels and those are not low. Those are actually relatively high. Then you know that the problem is not primary, but secondary. The problem is with the anterior pituitary, okay? And then there are also tertiary hyposecretion disorders. They are not diagnosed as often. It's hard to do diagnostics with the hypothalamus because of the blood-brain barrier. But if the problem was same symptoms, you're exhausted, you're gaining weight, all that kind of stuff, but then you tested all three levels and you got low, 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 that tells you that the problem is actually with the hypothalamus. So that would be a tertiary hyposecretion. So let's address one little thing that I told you that I'd address. Okay, so when we were talking about the primary hyposecretion, what I said was, okay, this was low, but this was actually high. Oops, not that one. Drew it in the wrong place. This was high, and this was high. Why? Well, what happens is you're making plenty of TRH and plenty of TSH, right? And you're trying to stimulate the thyroid, but it's not responding and not making enough T3 and T4. And what happens is there is not T3 and T4 to do this negative feedback inhibition. So these two actually start increasing in amounts. It doesn't happen instantaneously, but it definitely does happen. Okay, so now let's talk about hypersecretion, primary, secondary, and tertiary. And it's really just the opposite, right? So you're making too much of it, but are you making too much of it because of the thyroid, the anterior pituitary, or the hypothalamus? So let's look. If I had a primary hypersecretion, okay, of thyroid hormones, and it can be other hormones, we're just using thyroid as an example. What would happen is I would go in, I would have had maybe some exophthalmos, some weight loss, sleep disturbances, all kinds of maybe anxiety, and they test, and this level is high, okay? And then they test your T3 and T4 levels are high, and then they test your TSH, but it's not high, it's actually low, and your TRH is actually low. What's going on there? What is going on there is the thyroid is over secreting T3 and T4. Maybe you've got a benign tumor. There's also an autoimmune hyperthyroidism that I'll explain to you in just a minute. Okay, so with that, what happens, the thyroid is the problem. It's secreting boatloads of T3 and T4, and that is inhibiting TRH and TSH from being produced. So that would be a primary hypersecretion. A secondary hypersecretion would be go in, same symptoms, check for T3 and T4. It's high. Also, though, TSH is high, but TRH is low. Again, why? Because T3 and T4 are feeding back. Okay, but you could also have a tertiary hypersecretion, and a tertiary hypersecretion would go 1, 2, all 3, and that then the problem is with the hypothalamus. Okay, so we'll come back to this in just a second, and I'll explain the autoimmune one for you. Okay, so there are also 2 other types of disorders that we have seen. There is hyporesponsiveness, meaning that the problem is not really the hormone level, it's the target cell response to the hormone. Either it does not have functional receptors, enough receptors, or can't respond can't actually do what you tell it to do. So that would be a hyporesponsiveness, and very rare, but there are a couple of hyperresponsiveness disorders in which the receptor just goes crazy with just normal amounts of the hormone. Now, see if this will make sense to you. Sometimes this is a bit of a skull cruncher to people, but if you have a secretion problem and then don't fix it for a really long time, what it's going to do is cause an upregulation or a downregulation in the receptors, and the receptors will become more or less sensitive. So let's say you had a chronic hyposecretion issue. You were not making enough of it, and you didn't treat it, and you didn't treat it. Then what would happen is you would probably upregulate your receptors for that hormone, and then you would actually end up getting a hyperresponsiveness disorder. So it behooves you to figure out what's going on with endocrine disorders as soon as you can, because you could have started out with a hormone disorder and then ended up with a hormone plus receptor disorder. And this is actually part of what's happening with type 2 diabetes, which we'll talk about in just a second. Okay, so what about treatments for the different kinds of disorders? The responsiveness disorders are a little difficult to treat, as we see with type 2 diabetes. The secretion disorders are easier to treat if they're hyposecretion than hypersecretion, because we tend to know how to make most hormones in the lab by now. Not all, some we have to get from other places, but if it's a hyposecreted lipid-soluble hormone, you've got lots of possibilities for delivering it back. A lot of times you can take it orally because of the breakdown method. Sometimes you can use it in a patch or a topical cream, like estrogen creams, testosterone creams. You can use patches for hormones. If steroid and thyroid hormones can be replaced by a bunch of different mechanisms. And that is, of course, going all the way back to the metabolism chapter, because you do not completely break down lipids. If you have a small enough lipid, it can be absorbed kind of intact. And so you can take, for instance, an artificial T4 like thyroxine. You can take testosterone or estrogen orally. If it's a hyposecreted and it's a peptide or a protein hormone, you can't administer those orally because, of course, you break down peptides in the gut long before absorption at the intestine. You break them down in the stomach before absorption. So if it is a hyposecreted peptide hormone, you have to inject it, like insulin or growth hormone. And then what about hypersecretion disorders? Those are harder to treat. You have to figure out what the heck's going on and then decide whether you want to blast the tissue or surgically remove the tissue. So if it is hypersecreting and it's really problematic, then radiation is a possibility. Like with the thyroid, you can use radioactive iodine. You can surgically remove it. If possible, you could try to block the hormone synthesis. It's not very likely in most hormones. Or you can use an antagonist that actually blocks the receptor on the target tissue. Okay, so those are hypersecretion disorders. Now let's talk about hyposecretion disorders. So with hyposecretion, those are just the treatments. Sorry, the hyposecretion. What are some causes of hyposecretion disorders? Well, hyposecretion disorders, some of them are genetic, in which you needed a specific gene in the biochemical pathway or an enzyme to make a hormone, and you just couldn't do it. But some of them are related to a dietary deficiency. For instance, iodine deficiency can cause a hyposecretion of what, guys? What goes there? It's a hyposecretion of T3 and T4, okay? And then there are a decent number of autoimmune diseases that cause hyposecretion disorders. So Addison's disease, it's also called primary adrenal insufficiency. That is a hyposecretion of cortisol and aldosterone, or really both of the glucocorticoids and aldosterone. It's usually due to an autoimmune disorder. For some reason, tuberculosis pathogens cause an immune response. And then the immune response, the antibodies produced after a TB exposure, for some reason, they make a mistake and start destroying your adrenal cortex. And so a lot of people with Addison's disease were found to have had in the past TB exposure. Type 1 diabetes mellitus. Usually a combination of a genetic predisposition with an autoimmune trigger. And type 1 diabetes mellitus is a hyposecretion of what hormone? That's hyposecretion of insulin. And then Hashimoto's disease is a hyposecretion of T3 and T4. So here's two different reasons that you could have a hyposecretion of T3 and T4. The iodine deficiency one doesn't really happen very much in the United States because we add iodine to our salt, but it does happen in some places in the world. Okay, so those are your hyposecretion disorders, and then let's look at hypersecretion disorders. Hypersecretion disorders can be caused by tumors, benign or malignant, and there is one weird situation in which we've got a hypersecretion that is an autoimmune problem. So let's talk about a few of these. Acromegaly is hypersecretion of what hormone in adulthood? It is hypersecretion of growth hormone in adulthood. Pituitary gigantism was hypersecretion of growth hormone during childhood. And then, I don't know why that's on the same line. I'm going to put it on a different line. And then there is also an autoimmune hyperthyroidism. So hyperthyroidism could be caused by a tumor, but I want to explain this weird situation in which there is an autoimmune disorder that causes a hypersecretion, going back to the thing that we just did and saying, okay, so let us erase these for just a second and say, okay, so what happens with an autoimmune hyperthyroidism is have all the symptoms of hyperthyroidism. You've got sleeplessness and weight loss and anxiety and hair loss and all of that kind of stuff. And you go in and you measure and you say, okay, my level of T3 and T4 is high. Okay. But interestingly, my level of TRH and TSH are both low. And so you're like, okay, it's just a primary hypersecretion. Then they figure out that what's actually going on is you have a TSH mimic. It's called an agonist. It's pretending to be TSH. And what it is a TSH agonist, which means mimic. And it's really just an antibody. So I don't know if you remember, antibodies are peptides, but TSH is a peptide too. And so what happens is this antibody that was made to fight off, I don't know what, who knows, actually stimulates your thyroid and you continue to make T3 and T4. There is no tumor. And T3 and T4 will, of course, shut down the production of normal TRH and normal real TSH. So what you would have is high levels of T3 and T4 and all of the symptoms of hyperthyroidism, but no appreciable amounts of TRH or TSH. But when you looked for this antibody, you would have a whole bunch of this TSH agonist or mimic, resulting from, I don't know, exposure to some kind of pathogen that occurred in the past. Okay. So last, let's talk about hypo and hyper-responsiveness disorders. So with hypo and hyper-responsiveness disorders, the problem isn't really the hormone secretion, the level. The problem is that the target cells are not responding normally. So what could be going on there? Well, you could have bad receptors or too few receptors, insensitive receptors. You could have a situation in which the receptor works just fine, but the intracellular processes that you're supposed to do after the hormone binds to the receptors, those aren't working. So unable to start the signal transduction pathways. Or sometimes, remember me telling you that testosterone needed to be activated metabolically. If you release a whole bunch of it, but it's never activated metabolically, it's the hormone level's fine, but it's not working on the target cells. So, but a lot of times it's insensitive receptors, and we ran into two examples of these. So, type 2 diabetes mellitus, T2DM, is an interesting one. So I want you to think about this for just a second. So let's draw that one in there. So T2DM is a hypo-responsiveness of what kind of receptors? So what kind of receptors are not working normally? So those are insulin receptors, right? Okay. But why did that occur? What it is often a result of downregulation due to a really long-term hypersecretion of insulin. So what happens in this story is you eat like crap, you don't exercise, and you are constantly taking in sugar, causing more and more insulin secretion and more insulin secretion. Give that a decade, 2 decades. What will happen is you will start down-regulating your receptors, making them less numerous and less sensitive. And then what you end up with is a hypo-responsiveness problem. So hypersecretion caused downregulation, which caused hypo-responsiveness. Okay, but then you could also just have the problem genetically, like with androgen insensitivity. With androgen insensitivity, what it is a genetic problem with your androgen receptors. And so that is a hypo-responsiveness of androgen receptors, including testosterone receptors, right? And that was the androgen insensitivity syndrome, was when you are XY, but you can't respond to androgens. So you end up developing either mostly female development, mostly female looking, or an intersex development. Okay, and then this one, I just wanted you to have a hyper-responsiveness because you had a hypo and hypersecretion, and you had a hypo-responsiveness. This one is super hard to understand. I never ask about it, so just listen. Okay, so thyroid hormones, T3 and T4, are metabolic hormones. Yeah? But epinephrine also has metabolic effects, right? When you dump it into the bloodstream as a hormone, it increases the metabolic rate of like skeletal muscle and that kind of stuff. So what happens is chronic hyperthyroidism ramps up your response to epinephrine. So it causes upregulation of the receptors for epinephrine. So when somebody, for instance, with Graves' disease has a fight or flight response, their heart goes bonkers. So it causes a hyper responsiveness to epinephrine because those two metabolic hormones affect one another. But I don't ever ask you about that one. I just wanted it to be parallel. Okay, so the assignment here is for every disorder that we already discussed, you should try to determine whether the hormone represents hypo or hyper secretion or hypo or hyper responsiveness. Now, you do not have to know whether it's primary, secondary, or tertiary unless I give you hormone levels. So for instance, if I said that someone came in with all of the symptoms of Graves' disease and we measured their T3, T4, TSH and TRH levels, and I told you which ones were high and low, then you could figure it out. But unless I give you those levels, you cannot be held responsible for primary, secondary, or tertiary hypo or hypersecretion. Okay, so get all of your endocrine disorders that were in the notes, no more, categorized. Cool?